Hello, ladies and gentlemen. Today we're going to start our next unit, which focuses strictly on circles. For this, you're going to need your guided notes, something to write with, and a calculator. We're going to first start with understanding properties of some tangent lines. But before we can do that, you should know all the vocabulary that we need for the foundation here for circles. So here are some words that we should be familiar with, and I'd be able to identify on a circle. So circle itself is the set of all points that are equidistant from the center. The center is the point in the middle. The radius is the distance from the center to the circle itself. The diameter is a distance across the circle. It passes through the center. And chord, secant, and tangent are new to us. Chord is a segment whose endpoints are on the circle. A secant is a line that goes all the way through the circle. And a tangent is a line that intersects the circle at just one point. So these words and definitions here need to get written into your notes. You have the chart, so just write those definitions in there, and then we're going to illustrate them on the circle you'll see here in a minute. So add these pictures to your circle, or add these illustrations to your circle, okay? We're going to put them all on that same circle so you can see the subtle differences between them. So if we were going to start with the radius, remember, we'd start in the center of the circle here, and it goes out to the circle itself. The black part is the circle itself, okay? That big curve all the way around, that's the circle. Diameter is the purple. It goes all the way through the center of the circle, through the center. It's that distance all the way across. Okay, but new words for us, a chord, secant, and a tangent. A chord is any segment who has its endpoints on the circle. So that's one chord that we could draw. Notice both endpoints are on the circle. Whereas a secant is a line that extends beyond the circle but goes through the circle and hits it in two places. So notice that green line is a line that goes all the way through the circle. Now a tangent here, a tangent is a line that doesn't go through the circle or into the circle at all. In fact, it just touches the circle at one spot, and this will be called the point of tangency, where it touches. So these words we're going to need to be familiar with as we place them on circles, and we hear this vocabulary again in days to come. So let's take a look at just an example. Just don't need to write this part down, but take a look. Tell whether the line or segment is best described as a radius, chord, diameter, secant, or tangent of circle C. So segment DC. If you were going to highlight that on this picture, from D to C would be this part right here. What is that? Well, that would be best called a radius. What about B to D, that segment? B to D, that segment now, B to D, that would be a chord because it's a segment whose endpoints are on the circle. D to E, oops, we would call that one, oh, this pen is not writing. We would call that one a diameter. And then A to E, we would call that one a tangent, okay? A to E, that line, that's a tangent line. So being able to identify them on pictures is very important. There we go. Now let's take a look at the idea of tangent itself. So tangent means to touch at one point. Typically a line is tangent to a circle. Sometimes you can have common tangents. Common tangents are lines, rays, segments that is tangent two or more things, okay? So that two or more circles would share it, okay, as a common tangent line or a common tangent segment. So, for example, in your notes, this would be a picture of some common tangents. So you have two black circles and there's a blue line that goes through the middle of them like this. It touches the bigger circle here, it touches the little circle there. That blue line is considered a common tangent for those two circles. And same thing on the picture on the right. We have a touch spot here, it touches each circle in just one place. So this is a common tangent for both of those two circles. So here are some more pictures so that we're going to add in those common tangents. So let's start with A. If I was going to draw the common tangents for these two circles, I know that a tangent line would have to come along and touch both of them. So I could swing one like this, because it touches the little one here and the big one here. I could swing one like this, right like this, because it touches big one here, little one right here. But that's about all I could do. If I drew one out here, it would only touch the big one. It has to touch both. So this picture, part A here, has 2 common tangents. Now part B, how many common tangents could we draw for these? Well, we could draw them here, here, but we could also get a little creative and slice them through the middle like this and this. Remember, tangents have to just touch the circle, but they can't actually go through it. So this one could have 4 common tangents between those 2 circles. How many common tangents for this picture? C. We could do the similar idea here, here, but we could also slice one right in between where the 2 circles touch. That's where they would touch. So these points of tangency here are what we're looking for, and make sure that each circle has points of tangency for the same common line. So what we have here are 3 common tangents. What about D? How many common tangents could we draw there? Well, one circle's on the inside of the other circle. So we would have to draw our common tangent line, oops, right down there at the bottom where those 2 circles touch. That's where our common tangent line would have to be. So that has 1 common tangent between those 2 circles. Okay, let's look at that idea of circles being inside other circles. That's what's called concentric circles. Circles that share the same center are concentric. So think about the Target logo, okay? All these circles have the same center. That one has that as a center, blue dot. This one has blue dot as a center of it. So these circles are concentric. Let's take a look at some more things that we can do when we understand this vocabulary. So let's say AB is a tangent, okay? It's a tangent segment. Calculate the radius of this circle. So if we understand the different pieces of circles, you would recognize that from C to B here, that's a radius. That's why it's labeled with R. A to B, this length happens to be 12. And then A to C here, looks like it's labeled with an 8 and an R. And if we wanted to find the total distance there, we'd say that would be R plus 8 long. The R length plus the 8 length. So now if we were going to use something to help us figure out R, we should recognize that this is a right triangle, guys. And we know things about right triangles. We know first and foremost, the Pythagorean theorem will help me find a missing side of a right triangle. Let's take a look at how the Pythagorean theorem would work out here if we were to set it up. So the hypotenuse would be the R plus 8 length. So the other 2 legs would be R. So we take R squared plus 12 squared equals R plus 8, that whole quantity, squared. Okay, the R plus 8 is in parentheses because it represents a length together, and we're about to square it, so that's going to look a little different than what we're normally used to. So the left side here stays R squared plus 144, whereas the right side over here, R squared plus, or R plus 8 is a little bit different than R squared plus 64. That means that you have 2 R plus 8s being multiplied by each other. That's what this really means. So if we distribute this out, R times R is R squared, R times the 8 in the back is 8R, 8 times another R is another 8R, and the 8 times the 8 in the back is 64. So you may remember FOIL or double distribute. However you learned that in Algebra 1, please make sure you remember that now. So R squared plus 144, and then the other side is R squared plus 16 R's plus 64. So now we notice we have R squareds and R's. Notice that there's an R squared on both sides, so if we were to subtract R squared from both sides, that would essentially eliminate that problem. So we'd have 144 equals 16R plus 64. And now we go ahead and solve that. We're going to subtract the 64. We'd have 16 R's there on the right-hand side, and 144 minus 64 happens to be, 80. And then we'll go ahead and just divide that by 16, and we get R to be 5. Okay, so there's the radius. So notice we still need our right triangle facts and everything we've learned up to this point. We're just going to now start applying that inside circles. So tangent segments to a circle, if they come from a point outside the circle, they're going to be congruent. That's another nice fact to know. Take a look at this picture. This is what it means. It means if I have a point out here, S, and it is extending a tangent segment to here, tangent segment to here, that means these two will be the same length, okay? So those guys being the same length is very helpful when we have to take a look at solving a problem like this one. If I know that, if I recognize that those two are the same length, then I would just go ahead and say this thing equals that thing right there and solve. So 2x plus 2 equals 5x minus 4, and we'll get those x's together on one side. So we have 2 equals 3x minus 4. I'm going to add the 4 now. So we have 6 equals 3x, so x would be 2. Okay, so understanding the math that happens when we see circles in a picture, that's going to be our focus now for the next few weeks as we delve into this unit, okay? So I want to thank you for taking good notes and continue on. Thanks.